You can't see it, but it's here. In Alaska, in Greenland, and in Siberia. Permafrost, frozen ground that's so cold, it stays frozen even during the summer.
Permafrost is any earth material under ground surface which at or below 0 degrees Celsius for 2 or more consecutive years.
Approximately 50% of the Soviet Union is on permafrost, ground that never thaws completely.
Some permafrost has been frozen solid for thousands of years, but not anymore. Because of a warming climate, permafrost is warming too, challenging the people who build on it and live on it, and accelerating global warming even more. Permafrost makes up nearly a quarter of all the land in the Northern Hemisphere, about 8.8 million square miles. In some places like Siberia, the ground is frozen 1,000 feet deep or more. In interior Alaska, the permafrost dates back to the last glacial cycle.
We're close to 30,000 years old here.
10 miles north of Fairbanks, the U.S. Army Corps of Engineers Cold Regions Research and Engineering Lab operates a tunnel where scientists can research permafrost, its geological properties, and the fossils frozen in its walls. Dr. Matthew Sturm is their chief scientist in Alaska.
The permafrost tunnel was built in the 1960s. The reasons at the time were to see how do you dig permafrost. But with time, the tunnel, I like to think of it as a phoenix. It keeps rejuvenating itself. There's other new questions we can investigate. So modern questions now have to do with climate change, changes in environmental systems. But we're also interested in how to deal with permafrost because it's still a big issue in Alaska.
Alaskans have known for years all about the shifting nature of permafrost. Large parts of the Trans-Alaska Pipeline had to be built above ground on stilts to prevent the permafrost below from thawing. And Fairbanks, Alaska's second largest city, is dotted with pockets of permafrost. The sinkholes, collapsed roads, and tipping houses are clues to places where it has warmed. But now measurements around Fairbanks show that in many places, permafrost temperatures have risen so much that it is only 1 degree below freezing. At the University of Alaska's main campus, geophysics professor Vladimir Romanovsky runs the permafrost laboratory. He uses a Russian word to describe thawing permafrost, talik.
And talik, it means not frozen in Russian, just simply not frozen. It's very important now because these taliks start to develop because of warming and climate. And the development and growing of taliks is really indication of permafrost degradation.
Romanovsky has planted 45 boreholes deep in the permafrost all over Alaska. The results show that permafrost temperatures have warmed as much as 2 degrees Celsius in the last 20 to 30 years. Normally, because of the heat emanating from the center of the Earth, permafrost should be warm at the bottom and get colder as it reaches the surface. But exactly the opposite is happening. Romanovsky's data shows that since the mid-1980s, the temperatures in permafrost have gotten warmer as they creep towards the surface.
And this warming is 100% effect of changing in climate, warming in air temperature.
Thawing permafrost can take a toll on buildings and even force entire communities to relocate. But an even bigger cause for concern is the powerful greenhouse gas that gets released from thawing permafrost. Katie Walter Anthony was a young assistant professor when she made the discovery that permafrost thawing under lakes in Siberia and Alaska releases high levels of methane into the air. Methane is a greenhouse gas that's 25 times stronger than carbon dioxide.
If you look at the shore, you can see that there are lots of trees that are falling in the lake and they're dying. What's happening is the permafrost is thawing, and the ice that was in the ground, when it melts, causes the ground surface to collapse. Then the forest falls in, and any organic matter, dead plant and animal remains that were in the permafrost, thaw out in the bottom of the lake. Microbes decompose it, and it generates methane. And methane doesn't like to stay in water in solution. It forms bubbles, and those bubbles make their way to the surface.
Katie's dramatic videos of methane being released from frozen lakes have gotten her and methane a lot of attention.
So I've seen hundreds of lakes, thousands of lakes, and some lakes can release hundreds to thousands of times more methane than other lakes. And the most important factor is permafrost. If permafrost is around the lake and thawing beneath the lake will emit a lot of methane.
Even small releases of methane from the soil under these frozen lakes can make permafrost thaw more. That can help form more lakes that will release more methane, and so on and so on. Back in Vladimir Romanovsky's lab, his models predict permafrost warming all over Alaska in the near future.
By the end of the century, the only permafrost on the north slope and maybe in Brooks Range will be stable. Rest of it will be pretty much thawing by the end of the century.
Scientists at the National Snow and Ice Data Center in Colorado estimate that if global warming continues at current rates, up to 2/3 of the Earth's permafrost could be gone by the year 2200, vastly increasing the amount of greenhouse gases in the atmosphere. There's little chance that all the world's permafrost will thaw at once, and an even smaller chance that deep permafrost can thaw rapidly. But just ask someone living in the far north if permafrost is warming, and they'll show you. All they have to do is look down.